Okay, now that we've talked a little bit about the ideas of refraction and scattering, we're now ready to jump in and really understand how rainbows form. But just to do a super quick review up to this point, first, when we talk about atmospheric optics, the main idea is that 6% of sunlight entering the Earth is either reflected or scattered by the atmosphere. And this is what produces those colors, such as the blue sky or the white clouds. These are caused by the reflection and scattering of light in the atmosphere. Now, the idea of scattering comes from the fact that when visible light hits an object, that object then scatters the light in all different directions. The way that it usually works for cloud droplets is when the cloud droplets are really, really small, typically what happens is white light, which actually consists of all the different colors of sunlight, end up being scattered in all different directions. However, large cloud droplets do a really good job of scattering the individual colors in all different directions rather than the entire beam. And so the idea here is that these larger cloud droplets actually split the beam of sunlight up into its individual colors and scatters them in all different directions. The last thing that we talked about was the idea of refraction. And refraction occurs when visible light moves from one medium to another. And if it hits the boundary between these two media at an angle, that causes the light to bend. And this is one of the reasons why, if you've ever looked at something through a glass of water, the size may look distorted or it may even look reversed. And it happens because as visible light enters that water, if it enters at an angle, it bends. And then when it exits that water towards your eyes, it bends again. And so that distorts the view of it. So how does this actually relate to the formation of rainbows? Well, there's always been a few ideas of how rainbows form, and one of my favorites is in the form of this comic right here. A cloud that partied too much the night before and voila, got sick, and absolutely. But that's not really how they form, obviously. So what you need to know is in order for rainbows to form, you need a few things. One, you need sunlight. Two, you need water droplets, specifically large raindrops. And what happens is when sunlight hits those raindrops, the moment the sunlight enters the raindrop, it is refracted. Now, one of the things I haven't really talked about yet, but you can actually see it when you look at light hitting a prism, is that different wavelengths refract differently. And what that means is that when a beam of sunlight hits a raindrop, red refracts slightly differently than orange, than yellow, than green, than blue. And so basically, as soon as the visible light hits that water droplet, it splits up into all those individual wavelengths. And then each of those individual beams, each of those individual wavelengths, each of those individual colors hit the back of the raindrop and then come out the other end. They hit the back, they reflect, and they come out the other end. By the time they actually exit the raindrop, they're all separate colors. And so it looks something like this. So if you have sunlight entering a water droplet, as soon as it enters, it splits up into those individual colors. It splits up into red, orange, yellow, green, blue, indigo, and violet. And the angles aren't very different from each other. For example, the angle for red light is around 42 degrees. The angle of purple light is around 40 degrees. And then these these rays of light, these different wavelengths, bounce off the back of the water droplet and then back out the water droplet. They refract again when they leave the water droplet, and then they head towards your eyes. And that gives you the view of a rainbow. Now, one of the things that you should know about rainbows is the sun needs to be at your back. And the reason why this is because that sunlight needs to enter the water droplets, which will be in front of you, reflect off of them, and then come back to you. Now, if you're curious, however, why rainbows actually look like an arc, well, the way that it actually works is because these angles are between 40 to 42 degrees, when you actually take a look at a rainbow, that rainbow actually begins at an angle of 42 degrees from your eyes in all different directions. So 42 degrees to your right, 42 degrees to your left, 42 degrees above you, and yes, even 42 degrees beneath you. However, because there's solid earth down here, you typically don't get to see the bottom half of the rainbow. Another interesting fact about rainbows is, believe it or not, you are actually only seeing light refracting, only one color of light refracting from individual raindrops. So one raindrop refracts purple, and that hits your eyes. One refracts red, and that hits your eyes, and so on. But what I really want you to know, really the take-home message when talking about rainbows is rainbows form via refraction of sunlight as soon as it enters a water droplet and reflection off the back of the droplet. Now, what about double rainbows? Well, believe it or not, double rainbows actually are a thing. The only difference between a double rainbow and a single rainbow, what's called a primary rainbow versus a secondary rainbow, is that those individual wavelengths of light have actually bounced off the raindrop twice. So the sunlight enters the droplet, bounces off the back once, then bounces off the droplet twice, and then out towards you. Now, if you've ever been curious why double rainbows actually seem fainter than primary rainbows, it's because every single time this light reflects off the back of the droplet, it actually becomes dimmer and dimmer and dimmer. Believe it or not, there are even higher order rainbows. There are tertiary rainbows, quaternary rainbows, quintenary rainbows, sextenary rainbows, and so on. But we usually don't see those. We definitely don't see tertiary and quaternary rainbows because the sunlight or the visible light that's exiting those droplets are actually traveling away from us. In the case of primary and secondary rainbows, the visible light is heading towards us. But for tertiary and quaternary rainbows, the light is heading away from us. And then by the time we see quintenary and sextenary rainbows and so on, the light has become so faint that we really can't see it